Developing GPU-accelerated applications has become increasingly important in recent years as more and more industries are leveraging the power of GPUs to accelerate their computing workloads. However, developing and porting applications to different GPU architectures can be a challenging task, especially when it comes to migrating applications written in CUDA to new architectures. This is where hipify comes in. HIP provides tools for converting an entire codebase written in CUDA to HIP. There are many situations in which a programmer or researcher will need to run an application developed in CUDA for NVIDIA systems on an AMD GPU to compare performance differences. Prior to HIP, the only porting method involved the manual conversion of the CUDA source to OpenCL, which is a cumbersome and error-prone path. With ROCm, programmers can now leverage easy-to-use source-to-source translators. This can help reduce the effort required to port applications to ROCm and enable developers to take advantage of the benefits of ROCm's open-source ecosystem. These source-to-source translators make it easier for programmers to develop GPU-accelerated applications without having to learn new programming languages or APIs. ROCm provides tools for converting CUDA to HIP. These include hipify-clang and hipify-perl. These tools take CUDA source files as inputs and generate HIP files as output, including host-side APIs. The process of hipifying using hipify-perl tool involves three major steps. First, scanning. The hipify tool scans the codebase to determine what can or cannot be converted to HIP. Secondly, porting. Porting uses the translator to convert the CUDA files to HIP. Finally, verifying. In this step, the converted code compiles and runs. If we have a standard ROCm installation on our computer, we will find hipify-perl located in the opt/rocm/bin directory. The first advantage of hipify-perl is that it does not require CUDA to be installed on the system. This means that developers can convert their CUDA code to HIP without having to worry about whether or not CUDA is installed on the system. The second advantage is that hipify-perl does not require the source file to be syntactically correct. This means that even if the CUDA code contains error or is not written in a standard way, hipify can still convert it to HIP code. This makes the process of converting CUDA code to HIP code easier and more accessible to developers who may not have a deep understanding of the CUDA syntax. When working with CUDA code, we can use the hipify-perl command in the terminal to run converted code. The command converts CUDA code to HIP code and displays it directly in the terminal. The command hipify-perl print_stats square.cu is used to convert a CUDA source code file to HIP format using the hipify-perl tool and displays statistics about the conversion process. The print stats option in the command instructs the hipify-perl tool to display statistics about the conversion process after converting the source code file. These statistics include the number of lines of code, the number of replaced symbols, and the number of replaced function calls. This information can be useful to understand how much of the original code has been modified and to identify any potential issues with the conversion process. To convert a CUDA code file to a HIP code file, we can use the command hipify-perl in place square.cu. This command converts the original CUDA code file square.cu to a HIP code file, but also saves a copy of the original CUDA code in the square.cu.prehip file. This allows us to keep the original CUDA code intact while still being able to use the converted HIP code for programming on different hardware architectures. To view the HIP version of the code, we can open the square.cu file and see that it contains the converted HIP code. The next tool we will be discussing is hipify-clang, which is also part of the hipify toolkit. Now we will talk about hipify-clang. Hipify-clang is a tool based on the Clang profiler, which is a popular open source compiler infrastructure for C, C++, and other programming languages. When hipify-clang is used to convert CUDA code to HIP, it first parses the CUDA source code and generates an abstract syntax tree (AST) representation of the code. Hipify-clang then traverses the abstract syntax tree using transformation matchers. Transformation matchers are a set of rules that define how the abstract syntax tree should be modified to convert CUDA code to heap. For example, a transformation matcher might specify that all instances of CUDA-specific APIs should be replaced with equivalent heap APIs. By using transformation matchers, hipify-clang can automatically convert CUDA code to heap without requiring developers to manually rewrite their code. Hipify-clang distinguishes device and host function calls and includes the required header files. One thing to note, care must be taken to ensure that the input CUDA code is correct. All the includes and defines must be accounted for. Incorrect code will not be translated. Errors will be reported. Hipify-clang also support the clang options like -i, -d, and -CUDA path, etc. Now we will see how we can use the hipify-clang tool to convert a CUDA code to a heap code. The command hipify-clang vecadd.cu --CUDA path equals to user/leave/CUDA is used to convert a CUDA code file named vecadd.cu into a heap code file named vecadd.cu.heap using the hipify-clang tool. The --CUDA path equals to /user/leave/CUDA flag specifies the path to the CUDA toolkit installation directory, which is required by hipify-clang to find the necessary CUDA libraries and header files. This flag ensures that hipify-clang can locate the CUDA libraries it needs to perform the conversion. In comparing the hipify-perl and hipify-clang, we can observe that hipify-perl is more user-friendly as it does not require the installation of CUDA on the system, whereas hipify-clang requires the installation of CUDA. However, hipify-perl has the disadvantage of not being able to expand some macros correctly. On the other hand, hipify-clang provides more robust translation capabilities, making it more suitable for larger and more complex projects. Therefore, hipify-perl is a better fit for smaller and simpler projects. Finally, before we finish, I want to highlight that other than the source code, there may also be some other files in your code project. For example, you may have CMake or make files. Hipify-perl or hipify-clang will only port your code but not the auxiliary files. So before completing the porting process, developers should also check the compilation files and other files that are used by the project. In general, the command line argument passed to the heap compiler are similar to the command line arguments passed to the CUDA compiler. Therefore, the modifications should be easy.